Everybody, welcome back to Chem 300. We are in chapter 4 talking about ions in this lecture. So ions form when atoms gain or lose electrons. So we're going to be talking about the formation of ions throughout this section of chapter 4. So an ion is a charged particle that's formed from the atom gaining or losing electrons. So anytime you want to figure out the ion charge, the charge of an atom, you can take the number of protons that that atom has minus the number of electrons that it has. So for example, if we look at neutral oxygen. For neutral oxygen, oxygen has 8 protons by definition. For it to be charged neutral, it's going to also have 8 electrons. So it'll be 0 or neutral overall. For oxygen ion, oxygen tends to gain electrons, so it's still going to have 8 protons, but oxygen likes to gain 2 electrons. So it's going to like to have 10 electrons. And as we start talking about electronic structure and electron orbitals in the class, we're going to talk about how we know that oxygen wants to gain 2. But for now, we just want to compute the ion charge. So if oxygen gains 2 electrons, it'll now have 10 electrons. 8 plus 2 is 10. And 8 minus 10, it now forms a 2- ion. Another example, let's do sodium. Sodium, when it's neutral, it has 11 protons. That's its atomic number. So when it's neutral, it's also going to have 11 electrons. Charge is 0. But sodium ion, sodium is a metal, so it likes to gain electrons. Sorry, it likes to lose electrons. So it's still going to have 11 protons, because otherwise it would no longer be sodium. But sodium likes to lose 1 electron. So when it loses 1 electron, it started out with 11 when it was neutral, it loses 1 electron, so now it has 10. So when it loses 1 electron, it's going to end up with a charge of 1+. So anytime you know the identity of the element, you'll be able to figure out the number of protons. And then if you know the number of electrons, you can always compute the ion charge for that atom of the element. So another example, elemental fluorine contains 9 protons and 9 electrons. So when it's neutral, if fluorine gains an electron, it's still going to have 9 protons, each have a charge of 1+. And now it would have 10 electrons because it gained 1, each with a charge of 1-. So now the total charge of that fluorine would be 9 minus 10, 9 protons minus 10 electrons equals 1-. We call this the fluoride ion. When nonmetals gain electrons, we change the ending of the name from INE, that means neutral, to IDE, that means it's in its ion form. Just a convention here, when we're writing these ion charges, you put the number part first, and then you put the charge part second. So a charge of -1, we write it as 1-. If we had a charge of +1, we'd write that as 1+, 2+, etc. So the number goes first, and then the plus or the minus sign comes second. So let's figure out charges based on subatomic particles. So we have 3 examples here. The blue dots represent electrons, the green dots represent protons, and the red dots represent neutrons. So let's see, example 1. Number of protons, number of neutrons, number of electrons. So in the first example, we've got 2 protons, 2 neutrons, and 2 electrons. So if we want to find the charge, it's the number of protons minus the number of electrons equals an overall charge of 0. Neutrons are neutral, so they don't contribute to the charge. We do example number 2. We've still got 2 protons, We're supposed to have 3 electrons here. I don't know what happened to that image there. Sorry about that. 2 neutrons, 3 electrons. So 2 minus 3 equals 1 minus would be the charge on example 2. Example 3 is supposed to have 1 electron to show the difference here. So we still have 2 protons, 2 neutrons, and in this case, we just have 1 electron. So 2 minus 1, the number of protons minus the number of electrons, equals the charge of 1 plus on that one. So again, the net charge on an atom or ion is determined by comparing the number of protons and the number of electrons. Protons are each positively charged. They each have a charge of +1. And electrons are negatively charged. They each have a charge of -1. So to figure out the ion charge, take the number of protons minus the number of electrons to give us the overall charge of the atom. When the protons and electrons are equal, when you subtract the two, you end up with 0 or neutral as your ion charge. When you have more electrons than protons, you're going to end up with a negative number, have a negative ion charge. If you have fewer electrons than protons, you're going to end up with a positive ion charge. So we have special names for these ions. When the ion charge is 0, that's called a neutral atom. No net charge. This is when the atom has the same number of protons and electrons. The atoms in elements, natural elements, they have a net neutral charge. If we end up with a negatively charged atom, we call that an anion. So if your ion charge ends up being negative, that's classified as an anion. And that happens when there's more electrons than protons. For example, if you have 8 protons and 10 electrons, more electrons than protons, you end up with a charge of 2 minus. And this would be classified as an anion because it has a negative charge. If you end up with a positively charged atom, we call that a cation. So cations have fewer electrons than protons. So let's do the example with sodium again. We had 11 protons, and if it lost 1 electron, it only had 10 electrons, then 11 minus 10 is +1. So this would be a cation. Fewer electrons than protons. Collectively, any atom that has a charge that's not 0, that's not neutral, is what we call an ion. So anions and cations are both types of ions. If it's a negatively charged ion, we call that an anion. If it's a positively charged ion, we call that a cation. So you can remember by remembering that cations have positive charge. And this cute little kitty cat, the cutest ion ever. So let's do some example problems dealing with figuring out ion charges. So what is the total number of electrons present in each ion? And then write a chemical equation to show the gain or loss of the correct number of electrons. So we have F minus. So F minus is the ion of fluorine. Which we would call that fluoride. When a nonmetal turns into an ion, we change the ending of the nonmetal name to IDE. So this is fluoride, like what you find in your toothpaste. So we have F with a 1 minus charge. So that means that our regular fluorine neutral gained 1 electron to become F minus. When the charge is 1, plus or minus 1, we just write the sign. You could write 1 minus, but it's much easier to just write a negative sign. So the total number of electrons in this, if neutral fluorine had to gain 1 electron to turn into F with a -1 charge, neutral fluorine starts out with 9 electrons, and it gained 1 electron. which means it has 10 electrons total now. Okay, let's do the same thing for B. This is rubidium. Rubidium is a metal, so it's going to tend to lose electrons. And when something loses an electrons from a neutral state, it becomes a positive ion, which is called a cation. So we start out with neutral rubidium. It's always our starting point, the neutral substance. And it has a charge of +1. So that means it had to lose 1 electron to get a charge of +1. So we end up with rubidium +1 plus this 1 electron that it lost. When we write these chemistry equations, we only use plus signs. So we would never put rubidium -1 electron on the left side. We'd put rubidium plus this 1 electron that it lost, showing that this electron is no longer part of rubidium. Something else to note in these is that the charges on both sides of the equation always add up to 0. We have neutral rubidium on the left side, and we have rubidium with a 1+ charge plus an electron with a 1- charge. And if we add that up, it equals 0 overall. So if we want to count up the total number of electrons, rubidium in its neutral state, it has atomic number 37. So that means it starts out with 37 electrons. It lost 1 electron, so they have to both add up to the same number on both sides. So that means it must now have 36 electrons. 36 plus 1 equals 37, and then both sides equal 37. So rubidium 1+ has 37 electrons. Neutral rubidium lost 1 to turn into a positively charged ion. Just going to move these up, give us a little bit more space. Okay, let's do the next one. So we have Ce, which is cerium 3+. So we're going to start out with Ce neutral. It's a metal, so it tends to lose electrons. So it's going to turn into a cation when it loses electrons. So losing electrons, you're going to write the lost electrons on the right side of the equation. We call this the product side. So it turns into cerium 3+, which meant we must have lost 3 electrons. So if we want to figure out how many electrons we lost, we have to look up how many electrons were in neutral cerium. 58. It's atomic number 58. So when it's neutral, it has 58 protons and 58 electrons. So +3 electrons over here. So we have to fill in the blank. It's 55 plus 3 equals 58. So this must be 55 electrons. So cerium 3+ has 55 electrons. Neutral cerium lost 3 electrons to turn into the 3+ ion. And last one, we have Zr 4+. Zr is zirconium. So we start out with neutral zirconium. It's a metal, so it's going to tend to lose electrons. So it's going to turn into Zr 4+, plus it must lose 4 electrons to turn into that 4+ ion. Started out as neutral, loses 4 electrons, so we have those 4 electrons it lost over here. So if we want to figure out how many electrons it has, we have to check how many it had as a neutral atom. The atomic number for zirconium is 40. So it started out with 40 electrons. It lost 4, so that must mean it has 36 electrons when it makes the 4+ ion. So this is an example of figuring out how many electrons are in an ion. It's kind of taking that ion charge thing and working it backwards. It's also giving us some of our first examples of writing chemical equations. When you write a chemical equation, you put what's called the reactants on the left side of the equation. You have an arrow that shows there's some chemical change happening, and then you write the products on the right side. And in chemical equations, we only use plus signs. So if something's gaining an electron, you put plus that electron. And if something loses electrons, like with all these metals, you put the electron on the product side because the neutral metal went through the chemical change, losing electrons. So the lost electrons go on the product side. It's like one of the products of that change. Okay. We could also do it a little bit faster by using this equation. I kind of showed you the long way because I want to show how to write those equations. Ion charge equals number of protons minus number of electrons. So if we have a charge of -1 on the fluorine, it has to equal the number of protons. Fluorine always has 9 protons by definition, plus the number of electrons, minus the number of electrons. So 9 minus 10 equals -1. So it has 10 electrons. We do the same thing with rubidium, has a charge of +1. Let's write my charge correctly. So neutral rubidium always has 37 protons by definition. So 37 minus 36 equals +1. So it has 36 electrons. Cerium, +3 ion, 3 plus. Cerium has 58 protons. It's its atomic number. 58 minus 55 will give you +3. 58 minus 55 equals 3. So the ion cerium 3 plus has 55 electrons. And the last one, zirconium, it's a 4 plus ion. So zirconium, by definition, is going to have 40 protons. Which means to be a 4 plus ion, it must have 36 electrons. 40 minus 36 equals 4. So you can use whichever method works best for you. The first one that I showed, writing those reactions, when you go into Chem 400 and especially Chem 401, you're going to get into what are called redox reactions and half reactions. And what I was writing there is like a brief introduction and example of what those reactions look like. But for this question, either way, to just show the ion charge, you can do it using this equation, or you can do it by writing out those reactions. So in your textbook, there's a really handy figure that I wanted to point out. It's a periodic table that shows some common ion charges. This is the one from your textbook. This is the one I posted online as a handout. The one I posted just gives you a little bit more information, but it tells you for certain elements the ion charge that they're most likely going to form. So for example, elements in the first column, the metals in the first column of the periodic table, they all like to make 1 plus ions. In the second column of the periodic table, these metals like to make 2 plus ions. Scandium right there likes to make a 3 plus ion. And then you jump all the way over to aluminum. Aluminum likes to make a 3 plus ion. Zinc and cadmium, they like to make 2 plus ions. And then silver likes to make a 1 plus ion. I remember these ones by doing like aluminum, it's in group 13. So the 3 corresponds to the 3 plus, and then I go backwards, 3, 2, 1, going diagonally down. Then you come over here to these non-metals, and the ion charges go -1, 1 minus, 2 minus, 3 minus. So like nitrogen and phosphorus, when they turn into ions, they like to gain through electrons to become 3- ions. Oxygen, sulfur, selenium, beryllium, when they turn into ions, they like to gain 2 electrons to become 2- ions. And the halogens, fluorine, chlorine, bromine, iodine, they like to gain 1 electron to become a 1- ion. So when we get into naming ionic compounds in particular, you'll have to start memorizing these particular ions and their typical ion charge to help with the naming process. Okay, let's do another example problem. So give the charge each atom takes when it forms an ion. If more than one charge is possible, list both. So potassium. So when potassium forms an ion, we can go back to our periodic table of ions. Potassium is in the first column of the periodic table. So it's going to make a 1+ ion. That means it likes to lose 1 electron. So potassium here, when it forms an ion, it makes K+ because it loses 1 electron. Oxygen. If you check oxygen on the periodic table showing ion charges, oxygen makes the O2- ion because it gains 2 electrons. So neutral oxygen is going to like to gain electrons. It's a non-metal, so it likes to gain electrons, and it prefers to gain 2 of them. So when neutral oxygen gains 2 negative charges from those 2 electrons, it becomes O2-. Okay, now we have cobalt. Let's check the periodic table for cobalt. Cobalt isn't listed as one of the ions that we can always predict its charge, these ones in gray. Cobalt's kind of right, let's see. It's kind of right there. It's in the transition metals. And it's not one of these gray boxed ones where we always know the ion charge. So we call this a variable charge ion, meaning that it doesn't have just one set charge. All these ones in gray, like potassium and sodium and lithium, they're always going to have this charge. So when lithium forms an ion, neutral lithium turns into an ion, it's always going to make a +1 ion. When sodium turns into an ion, it's always going to make a +1 ion. When magnesium turns into an ion, it's always going to make a 2+ ion. That's what the ones in gray boxes mean. They have set ion charges. But anything that's not in a gray box means it's a variable charge element, that when it forms an ion, the ions could have different charges. So the transition metals, all transition metals, they all make 2+ ions and then at least one other type. +1 other, at least. Some of them make, just 2 different ions, a 2+ ion, and then one other one. Some of them make 3 or 4 ions, possibly. So for cobalt, we can put that it's definitely going to make a 2+ ion. And then cobalt also likes to make a 3+ ion. So cobalt, 2+, all the transition metals. Except those ones in gray. Except those fixed charge ones. They all make 2+ ions. And then they all make some additional ion as well. For cobalt, it's 3+. As you get more into quantum chemistry and electron structures around atoms, how the electrons are arranged, you can predict what these other ion charges are going to possibly be. For now, know that all the transition metals can make 2+ ions, plus 1 or 2 or 3 additional ions. The only way to know at this point the additional ions is to look up for that element its common ions. And so if you look up for cobalt, what ions it likes to make, it's going to list 2 plus and 3 plus. And many of these transition ones that have multiple ion charges, if they're a common element, then you'll find those on that ions and elements handout on Canvas. Otherwise, you just need to look it up and be like Google or check in an appendix of a textbook what ions cobalt likes to make. And again, the transition metals, they all like to make 2 plus ions and then some other ones. And these other ones depend on the electron arrangement around that specific transition metal. Okay, so that concludes talking about ions for now. In our next lecture, we're going to talk about isotope, which is when the number of neutrons in an atom varies. I'll see you then. Thanks for watching.